So what does that mean for the future, like eVTOLs, which we really like? This is these electric vertical takeoff and landing vehicles, right? A lot of people are talking about air taxis, and so let me go through like one example of how our technology would impact that. First, and I'll show you, but compared to just a battery air taxi, using an advent fuel cell on a liquid fuel, you can fly a lot longer. You can refill it just like filling your gas tank. Just imagine you want to take an air taxi from San Francisco down to Palo Alto. If you were to look at the example of an air taxi battery, just battery powered, right? One trip, you'd only be able to carry 2 people. And then once you're done with that trip, it would take 3 hours to recharge that. But now if you had that same taxi powered by an advent fuel cell and methanol fuel as our hydrogen carrier, right? We could carry 3 trips, 4 passengers, and only 10 minutes you can refill that. So just on this back of the envelope calculation alone, you can actually imagine making a business out of an eVTOL.
Welcome everybody to Wall Street Reporter's next Super Stock live stream, where we bring you those stocks which have that 10x to 100x upside potential. Companies going after massive multi-billion-dollar opportunities that are at a key inflection point and with multiple catalysts in place. And we are back with Advent Technologies, ADN on NASDAQ. Stock has been exploding since first launched last week. And now we're going to learn about the fundamentals about this, really how ADN could be shaping the future of aviation. This is something that I think most of the public, most of people following the stock are not even aware how big this can be. We're talking about drones, we're talking about air taxis, possibly space. So we're going to get into the details. So we have with us, obviously, Gary Herman, the CEO. Gary, say hello so people know who you are on the screen.
Everyone, hello. For those I met last time, welcome back, and to the new attendees, nice to meet everyone.
And then we have Emery DeCastro, who's going to be doing the presentation. Emery is the Chief Technology Officer. Emery, it's your show. I'm going to disappear. You'll show the slides that go through the presentation, and I'll come back. Hang on a second. Let's see. There we go. I'll come back after you're done for some audience questions. I know we're going to have a lot of questions today.
Right.
So with that,
Jack, before we cut to Emery, I want to introduce him as our Chief Technology Officer. But more importantly, and he's very modest, he is the father of hydrogen fuel cells and internationally renowned for his research, developments, and advances on hydrogen fuel cell and alternative power. So with that, I will turn it over to Emery.
Great.
Okay, and I know Gary, you're on the road, so hopefully we have a good connection. I know you have some meetings out there at airports. Again, we're talking about the future of aviation, and you're meeting with potential clients. So hopefully we have a good internet connection. But if not, people will know what's up. Okay. So with that said, I'm going to turn it over to Emery, and I'll see you guys in a.
Good. Yeah, Gary, thanks for the intro, but I have to admit that the father of fuel cells started, I think, 1870, so I'm not quite that old, but thank you for the compliment. But what I thought I'd do today is talk a little bit more about what Advent's doing for aviation and how we're really changing what is going to happen with aviation. Before I do that, I really need to tell you a little bit about fuel cells, membrane electrode assemblies, and why Advent's membrane electrode assembly is so different and brings so many advantages to the industry. What you're seeing here is a picture in the middle, fuel cell stack. A fuel cell is just like a battery, but it continues to run as long as you feed it fuel, air, and hydrogen. That's what makes it so much different. That's what allows us to carry a lot more energy than a battery can. What makes us different than all the others is we can operate at high temperature. And I'll explain why this is important. But number one, it allows you to use everyday fuels. So a typical low temperature fuel cell, something that operates below the boiling point of water needs super pure hydrogen, 99.99%. But once you can operate hot, basically the temperature of your oven when you're baking a cake, 350 Fahrenheit, all those poisons do not impact the catalysts. And so we can use a lot of different fuels like methanol, biofuels, ammonia, and that opens up the ability to actually feed our fuel cells with low-cost fuels that are available today. We have great interests for electric vehicles, off-power generation, drones, and marine. Today are just going to focus on aviation. So I mentioned this miracle plastic that we have in this orange and black thing you see in the center of the screen. That's one element of the fuel cell stack, membrane electrode assembly. So it's a sandwich. You're looking at the top side, that's an electrode. Right below that, there's a miracle plastic, a polymer, and below that, there's another electrode that makes up one unit. What makes our plastic with our membrane is so different is that it can conduct in the absence of water. And again, as I said before, it can get hot. What that means is that you don't have to carry water or worry about water balance when you're running these things. All right, so it gets a little bit lighter. Number two, probably the most important thing, thermal management. In other words, if you have something hot, it's easier to cool it. You always remember the ice cube trick or the water trick in your freezer, right? What gets colder faster? And indeed, if you put hot water in, the thermal gradient is steeper and you can remove more heat from that water. We work the same way, right? We can operate then at this higher temperature. We can build smaller radiators. And for any aviation application, drag is key. And if you have a big radiator creating a lot of drag as you go through the sky, the plane will not fly. And so this is why companies like Airbus, companies like Safran are working with us, because they realize they need to reduce this drag. We don't need these super high pure fuels. We don't have to worry about carrying water to keep our membrane conductive. And so it's really well mated to the aviation industry. So what does that mean for the future, like eVTOLs, which we really like? This is these electric vertical takeoff and landing vehicles, right? A lot of people are talking about air taxis, and so let me go through like one example of how our technology would impact that. First, and I'll show you. But compared to just a battery air taxi, using an advent fuel cell on a liquid fuel, you can fly a lot longer. You can refill it just like filling your gas tank. And we're open to using lots of different films. So just imagine you want to take an air taxi from San Francisco down to Palo Alto. If you were to look at the example of an air taxi battery, just battery powered, right? One trip, you'd only be able to carry 2 people. And then once you're done with that trip, it would take 3 hours to recharge that. But now if you had that same taxi powered by an advent fuel cell and methanol fuel as our hydrogen carrier, right? We could carry 3 trips, 4 passengers, and only 10 minutes you can refill that. So just on this back of the envelope calculation alone, you can actually imagine making a business out of an eVTOL. If you'd like to dive into the numbers, this is, some of the standouts. And again, this is basic calculations, but we're doing a calculation of a battery-only eVTOL versus the battery in advent. And we're assuming both will take the same weight. And if you look at the next line or the next line below that, the battery and fuel cell, the third one down, you can see that you need so many batteries in these things to give you enough energy to do your trip that it gets too heavy. But with a fuel cell and a liquid fuel, all of a sudden you do not need that much weight in batteries. And so you can replace that with people. And because it's a liquid fuel, you can essentially recharge it very, very quickly. And so this really gives you all the advantages you would need for an eVTOL to work. And we believe our technology has a great place in this technology. There's a nice startup down in Australia that we've been working with called Stralis. This is a Bonanza plane. It can take up to 6 people, and as you well know, Australia is a large continent, and this type of plane is used quite often commercially for point-to-point flying all around Australia. Australis has a goal to have this liquid hydrogen fueled plane going into a high temperature PEM stack with Advent MEAs by launching this plane, a demonstration plane, early in 2026. So we're quite enthused that this could be one of the early examples of showing our technology really making a difference in the aviation market.
Right. We will be the heart of the power plant for the Stralis aircraft.
Another interesting one that we really don't talk too much about it, and it's space. We have had a program with the European Space Agency, and it may seem a little bit complex, but let me lead you through how this all began. The satellites that orbit the Earth use a combination of solar and batteries. They use the solar to recharge the batteries, and then when the satellite goes around the dark side of the Earth, you start drawing down those batteries to keep the telecommunications going, communications going. What they found is that as the batteries get older, they lose their capacity, and there becomes time when the satellite's going through the dark side that there's just not enough power to power things. And so what we have shown is you can take an electrolyzer, you can electrolyze and pressurize oxygen and hydrogen. You feed that into an Advent high temperature fuel cell to create power. And so you do this electrolysis when the sun is out and you're using the solar cells to electrolyze water. Then once you're in the dark side, you turn on the fuel cell, you have your 2 tanks of oxygen and hydrogen, you feed those to the high temperature PEM. That creates electricity that really gets you thoroughly around the dark side. And the reason why they selected high temperature PEM is because of the vacuum of space, and it's so much easier to cool that stack when you have high temperature. Now, what we're looking towards next, adapting that same satellite technology into vehicles on either the moon or Mars, because you have the same issue, right? There will be times when you're in the dark, when you're no longer able to generate enough electricity and you cannot store enough in batteries, but this regenerative fuel cell, as we call it, the system, allows you to have plenty of power when you're on the dark side. So something that we're looking forward to very much. So I know I zipped through some of these examples and I'm looking forward to your questions, but basically high temperature PEM really is a superior technology compared to the other membrane technologies out there. It's really well matched for aviation, whether it be planes, eVTOLs, or even drones. And certainly, the timing, we're continuing to either seek strategic partners, but we're working with many others as well. So from there, I think we could take some questions. Thanks.
Thank you, Emery.
Okay, all right, guys. We're gonna get to the audience questions in just a second. I want to ask you, Emery, something. So, have you been in contact, for example, with Joby or Archer? So these are 2 public companies that are in the eVTOL space. They're trading at, Joby's at a $14 billion valuation, Archer is at $5 billion, and they're basically, I think they're, how close are they to commercialization, and can your hydrogen fuel cell really be the missing ingredient that they have? Because I think they're only able to do like a 50-minute flight right now with the batteries.
Yeah, what we really believe that the fuel cell that we have would be very competitive and really make eVTOLs worthwhile. Whether we're working with those companies or not, we're always under confidentiality agreements, so we can't. We can tell you what we can tell you, but we can't tell you what we can't tell you. So.
Okay. What about so the European Space Agency again? Like, what's kind of the status of that? Like, is it what's their goal with your hydrogen fuel cell technology?
So now they'd like us to increase performance, right? So for the satellite example I gave you, that's probably the smallest of the systems. but for for these off-terrestrial vehicles, whether it be Moon or Mars, it's going to be larger systems, but also lighter. And so that's the next stage for us.
Okay, so basically, I mean, the takeaway is essentially that the European Space Agency, which is like the NASA of Europe, they've hired you basically to power their space flight, if you will, in a way, the future of their next generation.
They see that, and yeah. Don't forget, whether it be ESA or even NASA, they look far into the future, right? And they set a very high bar for technological readiness. This is why I like that Stralis example, right? They're showing that, in fact, they could get a plane, up and going by beginning of next year. So.
Right. So Stralis is actually, when are they going into commercialization? Because I think they're doing, I think, a flight in a few months, right? They're doing a first flight a couple of months. And when are they going into actual commercialization?
Maybe I'll turn that over to Gary. You could.
They'll have to go through. Thank you, Emery. They'll have to go through a certification program, but the head start they'll have on what I'll say is a NUCO is that they are using an existing aircraft, which is the Beechcraft Bonanza, and that design of aircraft has been around since the late 1940s, early 1950s. So they foresee a relatively easy and straightforward certification process in Australia. And their airplane could be up as soon as the end of this year. If not, when we say early 26, probably January.
Okay. I think it's important to add. I think it's important to add, and I think, Gary, maybe you want to comment on this because your background is actually in the money management space as you're a fund manager. Is with these stocks, like right now, they're not trading based on like, okay, we're going into commercialization now. The valuations are based on what's going to be 3 years from now, whatever. For example, again, Joby, $14 billion valuation, Archer, $5 billion valuation. How far away are they from actually commercialization? I think not quite there. Right? A couple of years.
That's a very good point. They are trading at multiples of future revenue.
Right.
And Joby, I believe, possible future revenue.
Potential.
And Joby is backed by a big Japanese conglomerate, and they recently announced the acquisition. I believe they recently announced the acquisition of the New York marketplace of Blade, which is
I saw that.
publicly traded helicopter commuter company, and I believe the business model for Joby will be to take their product and eventually introduce it to the Blade New York marketplace.
Yeah.
So they're actually buying a future customer.
Yeah.
And future revenue for a marketplace.
Yeah. No, it's real interesting. But I mean, the way I see it coming from the investor standpoint is that ADN, it kind of fits right in that kind of intersection of this eVTOL stocks, like Joby and Archer, the space stocks, which I think there's a couple space deals out there. There's another one, I think Cooler, KUL. So there's and right now what I find compelling again about ADN is this thing is trading at the cheapest market cap of all. You're at 5 million value or 10 million. Now it's 10 million. Okay, 10 million valuation, which is cheap, especially based on, I think you have, what is that? Is it 150 patents that you have? The IP, can you talk about like the IP that you have and the position compared to their?
Right. Well, Emery can certainly talk to that. And what people should keep in mind, Jack, is we're a technology company. And our technology is our membranes, our proprietary membranes. And we believe we deserve a technology multiple on the stock.
And in fact, that is backed up by the strong patent portfolio, and it's very strong in the materials. When you think about energy, it's really advances in materials that makes it happen. Like we look at windmills, so that was an advance in carbon fiber technology. Well, for us, it's this advanced plastic material that is stable at high temperature conducts protons. And also, one thing to our company's credit, we look for the best out there. And this is why we've licensed the Los Alamos technology, because that represented such an advance in our field. And we're very aggressive. Actually, it was a competitive program, and we won based on our track record of commercialization, and continue to improve that technology with Los Alamos today.
Okay. I think also, again, because you have this kind of cutting edge technology, what's important is kind of, okay, is it real? I think that's what very important is. A lot of companies say they have this, they have that, this innovation. I think what validates what you have is, the partnerships that you have, again, you just mentioned European Space Agency. I wasn't aware of that. That's major. And of course you have Airbus, which is, I mean, that's like, I don't know if you can get a better, seal of approval than that. And then you have, innovators like Astralis, and there's probably going to be others in the space. Maybe even, I don't know, maybe possibly Joby Arch. I don't know. There's I'm sure. Listen, I think there's other companies out there, right? How many companies are developing these eVTOLs right now?
Yeah, I mean, there's a lot. I've lost track. Last I heard, I think there were over 100, 120 worldwide. But I also want to kind of bring up the other stamp of viability, and that's, I think maybe you've talked about this before, Gary, but this small unit that we make for defense, right? We call it the Honey Badger, right? That's using our advanced MEA technology in a package that's small and light, which, by the way, is perfect for smaller drones, right? We could, strip out some of the things that we do for the military, put that in smaller drones. If you have a drone that you just need it to be in the air for 30 minutes, a battery's fine, right? We're not going to compete. But if you want a drone in the air for 12 hours, for 24 hours, something that can carry a little bit bigger camera or something bigger, then pairing our technology on that drone, it's kind of a derivative of that Honey Badger power unit, would be perfect.
Okay. The drones out there that are like, what is it, like the Reaper, those drones that fly for, hours.
Yeah.
I think they go for like,
Right.
I don't know, 12 hours, 10 hours. They're using basically fossil fuels, right? They're also more noisy, right? They're noisy. It's one of the issues.
Very, very noisy. Yeah. And yeah, for some drones like that, certainly cost is not an issue, and, maintenance is somewhat. That's another part of our technology that many people skip over, right? We think about clean, we think about noise, but when you think about your electric vehicles, I don't know if you've ever had an electric vehicle, there's virtually no maintenance, right? People are begging you to do maintenance on these things, but they actually don't really break down. And I think a lot of people in the aviation space see the potential of low maintenance for electric planes, because that's a large running cost for any plane.
That's like the biggest thing out there, right? The maintenance costs in aviation is like enormous. That's like more than the cost of the plane sometimes.
So I believe that's what's driving a lot of the push towards electric planes. And then they find out, oh, the batteries are too big, they're too heavy, what can we do? And then they come back to us. So.
Okay. And again, I think in terms of the drones, like in military applications, the companies doing that stuff, which is, again, a huge market. So again, in terms of quiet, you have more of a stealth aspect. If it's, again, you have that kind of multi-hour long range and it's quiet. I think that gives it, so, okay. So you have it's a really interesting technology. I guess the main thing is going to be, okay, I think, okay, when Gary, I guess the questions are going to be, okay, what upcoming milestones are there that we could see actual commercialization contracts that will actually use the technology? How soon can we see, either drones or planes or anything else, which is going to have like a big sticker on it that says, powered by Advent technology, like the old Intel thing, Intel Inside. When is that? How close are we to that?
Well, for example, Emery, the slide you had before, you put up with the strawless aircraft, the Beechcraft Bonanza. If you look on the side of the engine, it has the Advent logo on it. And that airplane is powered by our membranes.
Okay, it's big. Let's get to some audience questions here. Hang on a second.
Sure.
I don't think we okay. So Question: have you explored expansion into rescue operations or possible partnerships with the National Guard, NATO operation? I guess similar. Okay, so I guess this would be more downstream, right? I think this is more of a downstream type of thing. This would actually be up
Even,
to
Homeland Security or rescue organizations with these honey badger units for sure.
Oh, the honey badger. I'm
You know,
sorry, I got it wrong. This is exactly the okay. This is what he's asking. Okay,
Actually,
honey badger.
that's why I thought the question. Yeah. Okay. Yeah.
So I'm sorry. So are you now? You have right now a contract with the Department of Defense for the honey badger. Do you? By the way, do you have the slide that you can show? So in case people aren't familiar, we can show what it looks like. The honey badger. I may have one. One actually.
Let me stop sharing. Yeah.
Okay.
We can both search a little bit.
Okay.
In the meantime, we can take another question.
Okay, hang on a second. Let me just pull up.
Right.
Yeah, we got it.
It's
okay,
in that
so,
presentation.
Okay, so here we go. This is the honey badger. Gary, Emery, I got it on the screen here. So the portable power.
Oh, perfect. Yep,
So-
there it is.
So this is the
yeah, and what? Yeah,
and you have a contract. It says you have a contract.
yeah. So
Gary, can you speak to that?
No, Emery's speaking about $2.2
Oh,
million.
Yeah.
Yes.
yeah, so the contract we have is to supply what we would call the last rev. Right, there was a certain size and a certain weight that we had to achieve, and we had been working towards that. And now with the next generation MEA from Los Alamos, we're able to make it smaller and lighter. So the current contract now is to qualify this last model using that advanced MEA. We've hit the weight, we've hit the size. So now we just have to show mil specs, which means dropping it, having it fall in a river, having it in the mud, all those things, which we've done before in previous models. So we're pretty confident that we'll make that last test through.
Okay. And okay, so when let's say you get through that test, when
Yeah.
will you be able to start generating revenues with this?
Yeah, Gary, we kind of look at our plans, and I think for what would I say is if we pass the test, then we'd expect some revenues in 2026, right?
Yes.
A little bit of the test sequence is a little bit undefined right now. They like to keep things like that under their belt. So there's some uncertainty in that band, but 2026.
Okay. And so here's, I think, back to the question. Okay, so I guess back to the audience question is, I think he was asking about. Okay, so this is being used in the military, this portable power, and what about other militaries like NATO, National Guard, other.
Yeah, we let's just say we also believe that NATO would be a good market for this. We're exploring that today.
Any military agency, NATO, armies of our allies, any one of them is a perfect customer for this. As I mentioned on our last call, Jack, portable power. If you're in the field, soldier, you need power for your satellite phone, your computer, your night vision scopes. Everything is powered today. And as we said last time, you're not gonna bring the Honda generator out there and crank it up. You go out there with a honey badger and you flip a switch and you have silent power.
And also, I think the main thing is that this weighs only 25 pounds fully loaded with the fuel versus, I think you mentioned 100 or 125 pounds other alternatives out there.
Right. The alternative is lithium-ion batteries. So 125 pounds of batteries is the equivalent of a honey badger. with several
Okay.
canisters filled with
Well,
methanol.
actually,
So it's a huge weight reduction.
Huge. No, because again, these guys have to carry it,
Yeah,
right? So there's a big difference between
exactly.
carrying 25 pounds on your back all day or 125 pounds. I mean, major,
Correct.
major difference. I just noticed something. We haven't even talked about this. In the slide, it says actually multiple applications expected in the future, including robotics, agriculture, and drones. We haven't talked about robotics. So I think we touched on it briefly for a second, but but Emery, can you talk about applications? Again, this is like future stuff. You got, again, aviation, these eVTOLs, air taxis, drones. I mean, everything is converging together. We get this like convergence of these technologies. And what about applications in robotics? Like, what kind of applications could this be used for? Emery?
Yeah, actually, I'm very excited over the potential of this in robotics. You've seen some of the amazing things that they've done, the robotic dog, or robots that can go upstairs or things of that nature, but they are severely limited by power, severely. And so we envision, our fuel cell either being on board to help power that robot, or even having remote powering sites where we have a stationary version of our fuel cell that a robot can go up to and basically be charged, remotely, instead of having to have a grid or anything else. You can imagine almost like a charging station in the middle of the woods that has our fuel cell, tank of methanol, where various robotic elements could go up and charge when they're out in the field. So we see multiple ways of enabling our power for robots.
Okay. Yeah, I'm curious in terms of existing, let's say, robots that are, these robots that are actually in commercial applications now. I think it's still very early in terms of the ones that we're thinking of, which are like these roving. I think that there's a couple of applications for like a roving security. There are like on little wheels or these delivery. The robots that are delivery. I think it's already on.
Yeah.
Actually in use on college camp. I haven't seen one, but apparently they're already semi-mainstream. How much what will be the difference between their existing using electric versus hydrogen fuel cell? Like, what will be the difference?
So for us, it'd be like an add-on, right? So you could actually add our fuel cell onto their system, decrease the weight of batteries, but still have some batteries, and then use our fuel cell to charge the batteries. And here's the thing. Instead of having to wait or plug in and then charge overnight, all you do is refill with a fuel, whether it be hydrogen or methanol. So you can quickly refuel and keep that device going. So your usage time increases dramatically, and thus, your kind of return on that money to spend gets better because you're using it for a full day instead of charging it for half a day and then using it half a day.
Okay, so that's a big difference. Okay, the usage time in terms of, okay, so like,
Yeah.
I think you addressed this earlier, like with the eVTOLs, like the turnaround time, like you could be up in the air for more hours generating revenues versus recharging for hours at a time. So this is very interesting, especially for these, like, again, like these roving robot, the ones that do the food delivery.
Very much so.
Yeah.
Well, and the important thing there, as Emery touched on, is if you're using this technology, you don't need to be powered up or connected to the grid. You can place the unit somewhere remote, have a large tank of methanol, for example, and maybe that tank's refilled once a month, and the device can keep on doing what it's doing off grid. Think about the cost in bringing power on the grid to a remote area. You have to lay power lines, insulated power lines, whether you're going to bury them, and they usually have to be buried several feet underground, or if you're going to hang them from towers. We don't do it from trees as much anymore. So just think of the cost of doing all that.
Yeah, I mean, especially like, if you talk about applications in like emerging economies, let's say, or the developing world. We're talking about India, Africa, parts of Asia. Or look at the war in Ukraine, right? I mean, I don't know if they can recharge. They're actually using this is like real applications of robotics, right? They're basically trying to use robots now, not just drones, but like robots to drop bombs. And they don't have exactly they don't have really time to, I guess, recharge or have places to plug in. I mean, I don't think they're saying, okay, guys, climb out while we we recharge. Question, an interesting question. Javier is asking, how are related to hydrogen explosive effect? Is this explosive?
Yeah, actually, I like this question, and I have a few answers. So if you think about a hydrogen-fueled car and you're at the hydrogen station, what happens with hydrogen flames is they go up, right? So you would just have to drop to the ground. If the same thing happened at the gas station, there's no way to escape that gas fire, right? Because it's at the ground, you have to walk through it. So just to say that, for gas systems and hydrogen, there's a lot of safety built in, but there still is potential. However, not to dwell on the honey badger over and over again, but that fuel is actually a mixture of methanol and water. So it's not explosive. In fact, they've shot these things with machine guns, and except for holes, nothing happens, no fire. So this hydrogen carrier, what we call methanol, which is really windshield wiper fluid, is relatively safe. Some people say toxic, but there are actually bacteria in the soil that break down methanol today, so it would go away naturally. So
it's the ultimate clean fuel.
Ultimate clean fuel. Okay, no, very interesting. Okay,
yeah.
Gary, I think we got a question for you regarding. Okay, so the company did the S1 filing. There's a capital raise, and there's always confusion about these, the equity lines. Can you explain to investors exactly because I think there's misconceptions always with these things that people think, okay, there's going to be $50 million of stock hitting the market. Explain exactly the realities of how this works.
Right. The reality is we did file an 8K that we would raise up to $52 million in equity line of credit, and we that same day also filed an S1 only registering just under 1 million shares of that total.
Okay, and I think, it doesn't mean that this 52. This could be over who knows how many years. It's not. It's
correct.
There's just going to be maximum potential. It's not like there's going to be all of a sudden this week, because it would be impossible.
That's correct. That's the maximum. But again, come back to the S1 we recently filed. It was for 987,036 shares of stock. So, based on the volume of the stock, we don't believe that would be very impactful.
This would probably be maybe over the course of a month. If you did the raise, it would probably be over the course of roughly maybe a month. So it's not. I don't think it would have any.
Maybe.
Question. Okay, I think Karina's asking. Okay, so the hydrogen fuel cell mixture, it's methanol and water. I think we have a delay on the stream.
There we are.
I think there's an there's a lag. Gary, can you hear me?
No, I hear you. Emery, the
Not
question
Gary,
is
Emery.
Yeah.
I think there's a lag on Emery.
I can hear you. Yeah.
Okay.
So
the
mixture
mixture.
Is there a question about methanol and water?
Yeah. Okay. Okay. Good question. Okay. What are the competitive challenges facing your company? Competition, technology, whoever wants to address that question.
Emery, you can take first crack at it.
Yeah. One has a little bit of history, right? The prevailing plastic technology is called low temperature PEM, right? That got its start in 1966 with DuPont. So they've had 60 years of development. It's well entrenched, even with all the problems that it has. So for us, we're a relatively newcomer, roughly 10 years behind our technology. And so for us, part of it is educating people that this high temperature PEM can overcome the limitations of low temperature PEM. number one. Number two, there's always performance and power, right? And people want as much power as possible. Today, we're not quite at the level of power generation as low temperature PEM. And we continuously work and we see a path where we should be able to be equivalent to low temperature PEM, if not better. And that's what we're working on today. However, it's why we like Stralis, because Stralis is telling us the plane will fly with the power that you're generating today, which is a great first case example, as well as the Honey Badger. But certainly the higher power we can achieve, longer lifetimes, that turns into a lower cost of ownership for all our customers. And so that's one of the key technological challenges that we're working on.
And lighter weight. And Jack,
And lighter
this is
weight.
why Airbus, with all the choices they have as a multinational conglomerate, and as you said, and really, it's the seal of approval in aviation came to us because they understand what our technology can do and the future of aviation with using our technology.
Okay. No, very interesting. Okay, so I think the main catalyst in terms of the big catalyst, I think that people, or I should say investors at least, are going to be watching is really Stralis. Actually, when they get this aircraft up in the air, it actually flies for I guess how many hours could it fly with your fuel cell now versus how many hours? How many hours of
Yeah, that's a good question, and that's an engineering trade-off, right? So the hours accounts to how much liquid hydrogen they can put on the plane, which means a certain weight, which means limits. So those type of things are right within what Stralis does a lot more. We focus on giving them the power that they need. So
Okay. I think they said basically I think in the press release they mentioned 10 times more than batteries. I think with
yeah,
batteries we saw like the batteries are like maybe an hour. So this is multi hours of flight time basically.
yeah,
We have multiple hours of flight time. So I think it'll be interesting to see like, and this is going to be in the coming months. They're actually,
Oh yeah,
this is going to take off.
yeah. And Jack, just to
If
keep
you
in
have it,
mind, even with airplanes that are fueled with avgas or Jet A, there's always a weight and balance consideration on the number of passengers and cargo versus the amount of fuel you take on board. And that's why when you fly, the pilot and co-pilot are regularly doing weight and balance calculations.
but interesting, the Bonanza, right? The one that they're putting
Mm-hmm. Yes.
your hydrogen fuel cell. That with normal, with normal gas, it's what probably like a 4 hour. It's got 4 hour
Yeah.
flight time roughly.
Probably 4 to 5
So,
hours with um
so
with uh with regulatory backup fuel.
okay, so basically the hydrogen fuel cell is a pretty good alternative. I think based on again we don't know the real numbers yet, but it looks like it's equivalent to traditional fuel right now. Fossil fuels, whatever we call it, traditional aviation fuels, right? So it's
Mm-hmm.
basically the same thing. What we're going to see, basically in a few months the real world case, the real world demo.
Yes.
yeah.
Let's see. Okay, so we talked about competitive challenges. Okay, so let me ask you this. Okay, so let's say we have a couple of important milestones coming up short term, right? We have
Right.
obviously we got Australis. We have the Department of Defense, which is the mil spec challenge coming up. After that, I think you have a couple other things. What assuming everything goes well, you meet these milestones.
Mm-hmm.
What could ADN look like 3 to 5 years from now for those, potentially long-term investors interested? I know everybody here is really more, 6-month maximum time window, but if anybody actually has a long-term perspective, what's the potential for Advent Technologies? Like where could this be? How fast is the market moving, in terms of in the direction where you're at right now?
Well, I mean, Jack, I'll just jump in, and Emery can certainly address the technical. I would go back to what you said a little while ago. Powered by Intel. We want to. We want airplanes, robots, drones to be powered by Advent. And that's why I go back to, what is Advent? We're a technology company, hydrogen fuel cell technology. We are an innovator in the space. We see not only we have our technology, improving our technology, and also partnering with the right partners. Airbus for what we'll call commercial aviation, the United States Department of Defense, Stralis for general aviation. There's numerous super yacht builders around the world we see using our systems for backup power on the ships. Eventually, cargo ships. Just again, anything that is operating on
Yeah.
fossil fuel today and requires power. Now, we're not going to
Yes.
cover
Yeah.
every company in every industry out there, but as we touched on last time, if we're focusing on aviation, marine, drones, UAVs, space. I mean, those, and as well as the United States Department of Defense and related industries, Homeland Security, the defense forces of our allies around the world, tremendous markets. And you only need a
It's
sliver of each one to move the needle.
Yeah, again, because the market cap of the company is only like 10 million right now. So this thing is like very deeply discounted. Usually these stocks get like super overvalued based on like, a lot of the upside is kind of pulled forward. I think that could be the case with Joby and Arch. I mean, the valuations are crazy for where they are right now. But in your case, it's actually just the opposite. You're at a 10 million market cap. The value of the IP could be 50 million plus. And it's interesting. Now, you mentioned actually use in shipping and marine, and that's people. I think most people, 99% of the audience, they're not really aware of it because most people have very little contact with shipping and boats. But in terms of these tankers, cargo ships, which is, I mean, that's the all of world trade basically revolves around shipping. The most goods are shipped, and one of the big challenges is, obviously the fuel cost is expensive, right? And I think do they still use, I think there was a thing called bunker fuel, which is like a very dirty diesel, or
Yeah.
they use very dirty, cheap fuels, which are highly pollutive, and they're trying to do, I think they've been so this could be a very good alternative for that. Obviously, for high-end boats, it's quiet also.
Jack, you
versus
really
diesel.
put your finger right on it. So you may not be aware, but if we just think about either cruise lines or luxury boats, right? There are actually some places in the world, in the Caribbean, in the Mediterranean, that will not allow a cruise liner to come in and idle their engines to generate electricity, right? Not even propel it, but just to generate, because of that pollution footprint. That is actually double that down for luxury yachts, especially in the Mediterranean. There's a code now that actually forbids them to run their diesel genset when they're in port. They cannot do it. So they either need landline or some other way to get electricity to run the air conditioning, the wine coolers, all those things. And so, what we're seeing is essentially electrification of power, right? Whether it be cars, planes, yachts. I think everyone can see that trend is happening. That is our 3 to 5 year trend, right? Electrification.
Yeah.
And we believe that our fuel cell technology is key to enabling that power.
It's interesting. I would think that in terms of like low hanging fruit where, your technology could be commercialized the fastest. I think it could be obviously, things which I think probably will be in applications where it's not like there's a potential like unknown or safety, like aviation. Everybody's like, we got to have millions of tests. It's much more involved. But something which is like low risk or very, again, like the honey badger, or like, for example, generators on yachts or shipping. That's something which people consumer, basically a boat owner would say, hey, you know what makes sense to me? How much is the system versus a Kohler generator, whatever it is. And it's quiet. I like this. It's not going to make noise. It's going to be whatever. And I could deploy it tomorrow. And by the way, the price is not a big issue for, if you have a 50-foot yacht, or which is not even that big anymore. It's like, but the
Right.
bigger ones, it's not that big of a deal. How much could the system cost? How much would your system cost actually in dollars for a generator, fuel cell, using hydrogen fuel cells?
Yeah, I think we've done some TCO comparisons of some diesel gensets, versus fuel cell. And after about 5 years, we come out lower cost of ownership. And a lot of that comes because of maintenance, right? Lower maintenance cycles. So.
Oh, the maintenance is a big deal. Maintenance is a big deal. Okay,
Yeah.
huge deal.
Yeah.
Yeah, because it's especially you're out there, having a nice ride somewhere, or you're anchored off, I don't know, wherever in the Mediterranean. Your generator breaks down. You got to call a mechanic. Where are you going to get the parts?
Right.
Fuel. It could be a nightmare.
We have right. There's fewer moving parts.
Fewer
on our
moving parts,
systems.
easier. The decision-making process is it's a simpler process, and it's basically just a individual boat owner versus having the FAA, the government agencies, whatever, whole decision making process. So the decision making, the path to commercialization, it could be. I mean, Gary, is that? I mean, I'm just taking a guess. Is marine actually, is that, or the honey badger? Which one do you think will be the first one that's actually going to get to? Which one is going to get to commercialization first?
I think they're both very prime markets for us. And to go back to the honey badger for 1 second, as we touched on our last call, it's not just the military. Think about people who go camping. You need portable power. We can do that. You go hiking, you need power with you.
RVs, that's all these RVs. That's a big thing. People love
Exactly.
RVs.
Rather than having to run a noisy diesel generator at night, if you don't have an ability to plug in at a campsite, you just flip a switch. You have quiet power from our fuel cell.
Yeah, it's interesting. We're talking about fastest path to commercialization. Actually, robotics is actually the same thing, because it's the same. They don't need approval from the FAA or government. It's right there. The only difference is the robots are still it's moving fast. The market is going fast, but these applications are like there now. But who knows? But anyway, listen. I think what I find exciting is you got multiple catalysts. You really have multiple paths for commercialization, which could really move the needle for the stock. And also, I don't think it would take that much, again, because the market cap is so cheap. I think people need to appreciate this.
Right.
The stock, the valuation is so cheap right now that even a small win in the commercialization space could really move the needle. It wouldn't take a lot, like very little.
100% agree with you.
So to get especially as opposed to the Jobies or the Archers of the world. Okay, enough about my opinions about valuation. All right, do we have any more questions?
We agree with you.
Okay, no, I think we're done with the questions. Okay, guys, I want to thank you. Thank you, Emery. Thank you, Gary, and thank you everybody for joining our live stream today. Let's do another one. I think maybe we should do maybe in a few weeks about other applications that you have, other news flow for sure.
Absolutely, we
Gary,
look forward to that. Yes.
Before I let you go, I think somebody was asking what do you have? What kind of news flow? Because again, I think what investors are looking for is, okay, what kind of milestones, catalysts do you have coming up the next 30 days, 45 days? We always ask that because we always want to know.
There's certainly a lot going. I can say there's certainly a lot going on at the company, and we are eager to let the public know what we have going on at the company. And as I touched on our last call, and I know Emery has the same daily routine. We're operating off of multiple time zones every day. New York, West Coast, Greece, where we have a major facility, Europe, Asia. So there's a lot going on, and we look forward to letting the audience and the investor public knowing.
Fantastic. All right, guys. Thank you, and we'll see you all on the next one. Take care.
Wonderful.